of the three curves directly, okay? So what we have here is, we have three curves, a low or a pessimistic curve, a base or average curve, and a high optimistic curve. The three curves are here, green, red, and blue on the chart, okay? And I would like to, create one curve here, the purple one, that resembles these three curves, that is somewhere in between these three curves, with most of the time in between, and that represents the uncertainty, the uncertain production I will observe based on three scenarios, three curves. This is very common. Sometimes you're getting this from, let's say, it's a joint venture, and another company is the operator of the project, and you receive just three estimates or three scenarios of what the production will be. Or you are using, Schlumberger's software or some other companies, the companies that have very specific software for estimating production curves, and the engineers provide you with three scenarios. How can you, instead of creating just a three scenario analysis, how can you create all scenarios in between these three? How can you create a simulation of everything that's possible, okay? By understanding what this low, base, and high mean, we can create a good simulation for that. So I'll assume that this is, let's say, P90, a very low estimate. This is mean, average, and this is P10 of my of all possible scenarios. By doing that, we can come up with one single distribution here to represent the reserves that we have. So I have here, this one single distribution is based on the cumulative total production of the project, or the peak production, or whatever you believe properly represents each curve. We need one single distribution to map the uncertainty around these three values. And then the model itself is kind of ugly, the equation. It's kind of large and ugly, but it's just a simple interpolation of what happens between low, base, and high. So based on one single aspect, I select the curve that will be somewhere here in between. And then we can make a simulation where you have very low, very high, even numbers beyond the maximum. Remember that my maximum is a P10. So 10% of the curves would be above this one anyway. So I'm accounting for that inside my model. So there's a chance you have higher or even lower curves than the lowest one you have here. That's my P90. There's 10% chance that you will see a lower curve than that, okay? So now we can simulate everything that may occur here in between just by interpolating the points of the curves. This is a very simple and straightforward way to transform three curves into a whole simulation of everything that may occur, or 5, 7, 10 curves if you want, okay? There's no theory behind it. The theory is one step backwards when they created these three curves. So maybe in another model, they had a very interesting geological study and they created the three curves for you. That's where the theory is. Now, based on the three curves that kind of represent the whole setup, we can recreate everything in between. Of course, this is a proxy of the real curves that we could have. So instead of having 1,000 or 5,000 scenarios, we have only three, and we can reproduce everything that happens in between, okay? All that we need is to understand what does low, base, and high mean. Those are not statistical terms, but that's the way people usually talk, right? A low, pessimistic, optimistic scenario. But what do you mean by pessimistic? Oh, that's my P10. That's the P10 curve of the simulation that the engineers generated. Okay, if that's a P10, I can now create one single distribution where I'm using P10 as one of the parameters, and I have a distribution to represent the uncertainty of the total production. With the total production, I recreate the curves that would generate that. So with this simulation, we can also recreate here. I'll run the simulation real quick here, just 1,000 scenarios to make it quicker. So we can recreate all possible scenarios based on that. So here's my distribution. Let me just run that again. So this is the total production I have with this project after 15, let's say, weeks of that production rate. This is the distribution of the total production over the lifetime of my project. And if I wanted to see what the production is per time step, I could also do that using at risk. Easy and straightforward. The equation is ugly, but it's just a plain simple interpolation of values. Okay, so we get curves that are actually parallel to the three scenarios we have. Okay, so that's what we're simulating. Then, of course, to be very easy to plug this back into your NPV model or economic model or whatever. Okay, just make the model read this curve on column H, and you have the production curve for each scenario. That would be the second approach here. Instead of a theory-based or a parameter-based curve, we have three actual curves that came from elsewhere. So theory is one step behind our model. With these three curves, it could be P10, P50, P90. It could be P10 average and P90. Whatever these three curves represent, we can recreate all the scenarios from these three curves. Maybe the distribution is not as simple as this. You could have 5 curves or 8 curves, 7 curves. I've seen companies using more than just 3 curves to actually represent better details here, the specific extremely high or extremely low scenarios. These curves, by the way, they don't need to be parallel. Maybe the difference between P90 P10 is the number of wells, or the usefulness or not, or of the injection wells, or the efficiency or whatever. So the curves may actually not, they don't need to be parallel, and the model still works. For example, I just tweak the curve here a little bit, make it not parallel anymore. So let's suppose that the low scenario here, the low scenario represents a slow but steady flow, and then the low scenario is even better than the base case at the end of the project. It even reaches what the optimistic case is at the end of the project. Of course, it's worse. We make less money on the blue scenario here, on the blue curve, but let's suppose that the curves are not parallel anymore. Yeah, that works. You can just get curves that are somewhere in between these scenarios. The methodology works no matter what the shape of the curves are. So that's a good thing. The theory behind how these curves are generated is back there in another model. It works. It generates scenarios that are realistic, and we now create not only those 3 scenarios but everything in between. So this method is very simple, straightforward, and solves the problem. So for quick simulations like this, or when the theory behind it is too complex for you to model that in Excel, or we have another process of doing that elsewhere, it's easy to export curves and recreate them in Excel using at risk for your simulations. Okay. As I said, some companies use 3, 5, 7 curves. What if instead of that they just dump you the 1,000 scenarios? They ran the simulation tools elsewhere, optimize the wells, optimize the position of the wells. There's a whole 2-3 month study to come up with the best well allocation for any kind of uncertainty that comes up, because of course you can react. Once you start drilling, you discover information and you change the position of the wells. And at the end of all that optimization study performed elsewhere, you get 1,000 production scenarios. How can I make a simulation out of 1,000 scenarios? And I'm not talking about just 1,000 scenarios of like the total production. I'm talking about 1,000 scenarios of the production at each individual time step. So I have 1,000 curves. Of course, this will be a little bit too complicated to set up for 1,000 curves, the interpolation